Hello everybody and welcome back to SkySaga Alpha 9. We're over here on the tutorial island. It is time for another bit of a Lumostone tutorial. So today we're going to be talking about this little guy here, and this is an advanced randomizer. Now, I've covered randomizers before, but the randomizer we built then was a little bit more predictable and it wasn't quite perfect. So we've gone through and I'm going to take some techniques we've used before and add in the exclusive OR stuff we learned in a previous tutorial, and we'll create this awesome randomizer here. So before I talk too much more about it, I'll stand on this pressure plate and you can see that while these guys at the top here are kind of going in a regular interesting pattern, this down the bottom here doesn't really seem to hold any particular pattern. It kind of goes all over the place. It is very random, and that's exactly what we want. These blue lights down the bottom are the output to this circuit. Normally when you build this web, you don't want to build these other two sets of lights. You only want this bottom set, because this bottom set is your actual output to this web. These two are just two intermediate stages that get XOR'd together to create this system down the bottom here. So yeah, as you can see, it's very, very random, so it's very hard to know when you step off what you're going to get out the other side. So that's exactly what you want with a random. You don't want the person using the random to actually know exactly what it is they're going to get when they step off the pressure plate, because that way they don't have any incentive to kind of mess with the thing and try and get exactly the code that they want. So basically how this thing all works is we have a 3-bit counter here. So we've done counters before, and then at the top we've got a 3-bit sequencer, and once again we've done sequences before, and then we XOR these together to get the total output. So basically the way this works is that this light here in the counter, the first light in the counter, gets copied down to the first light in the output line, and then this output here is an exclusive OR of this, the second dot in the counter and the first dot in the sequencer. So if these two things are the same, this is off, and if they're different, then this is on. And once again, with the third light here, the third light is an exclusive OR of this guy and this guy, so the third light in the counter and the second light in the sequencer. Now, that does mean that we're having a third light in the sequencer that we're not using, but that is okay, because that means that there's actually a bit of time where one of these two lights isn't on, and that's a good thing. Adding kind of extra stuff into this that doesn't actually do anything to the output just adds time delay to the output, so it actually makes it even more random, or at least slightly more random. It also means that because this guy here, the counter can count 0 to 7, or it can count 8 times essentially, whereas this goes and counts 3 times, which means that there's not really any overlap between those two, because it's the multiples of 3 and 8 are a lot further up than most people will bother to stand on the pressure plate for. So it's going to have, it does have a sequence, and the sequence will kind of repeat itself, but it's a very long sequence, so it seems as though it's random when you're viewing it for a short period of time. So anyway, let's just take a quick look out the back here. Now, all of this stuff out the back here is actually related to this. Oh, and I've taken my helmet off, that's why the G didn't work there. There we go. So there's a lot of circuitry going on around here. It is all of this stuff, all of that stuff, and all of this, other than those pressure plates there. So there's a lot of stuff going on, but like I said, this is just merging together bits that we've done before and adding a little bit of extra protection. So there's some stuff in here that we haven't done before, because it wasn't needed up until this point. So there's some stuff that we did with the sequencer I have stuff I've done here with the sequencer that hasn't been needed before. But anyway, so what we're going to do is we're going to head over to a clear patch of ground over here, and we are going to have a look at how to build this guy. So what you're going to need is you're going to need a bunch of different things. So as I said, this is just a combination of stuff we've built before. So you're going to need 3 latches, 9 AND gates and 8 NOT gates. This is for the counter. You're then going to need 3 latches, 13 AND gates and 11 NOT gates. That bit is for the sequencer and the sequencer protections. And then you're going to need 8 AND gates and 11 NOT gates. That bit's for the exclusive OR and the nodes that we're going to be creating to turn the lights on and off. Then you're going to need 1 AND gate, 2 NOT gates and a pressure plate. This is for the input stuff. And then of course you're going to need your final 3 output lights. So let's go ahead and start building this. So let's start with our input. Now our input is a pressure plate, as we've done before. So pressure plates are pretty much the only input we have right now. And then what we're going to do is we're going to hook up 2 NOT gates and an AND gate down here. So I'm just going to place all of these down in one quick go, and then we're actually going to hook them up. So the way we hook these up is we're going to hook one NOT gate into the other and then back again, just like this. So this creates a little rapid fire clock that we've done before. And then we're going to take the output of one of these and push it into the AND gate at the A side. And then we're going to take the output from the pressure plate and hook that into the B side of this guy over here. So there you go, that's our little input all done and dusted. Now the next thing we're going to do is we're going to go through and do the actual counter. So the counter is pretty simple and straightforward. We've done these before. That's okay, we'll still go through and do this on camera. So first of all, we're going to place down our latches. That is the correct way, yes. So we're going to place our latches down with a little bit of a gap between each one, just like that. And then we're going to place 2 AND gates for each latch, 1 and 2, 1 and 2, and 1. Oops, that's not where I wanted that one. It's going to go here and there. Okay, so once we've got all of those, then we want 1 NOT gate going into one of the AND gates, just like this. And now we can actually start wiring this thing up a little bit. So we're going to go ahead and take the NOT gate and put that into the A side of each of these guys. There we go. NOT gate into the A side. So this is the NOT gate goes into the AND gate ahead of it at the A side. And then we're going to go through and hook these up correctly. Now, this is once again just like a counter, so when the NOT gate is on, that means that the latch is off and we want to turn the latch on, so that's going to go through and go into the on side. Then the other AND gate, the AND gate with nothing hooked up to it, goes to the off side, just like that. And we do this for all of these latches all the way down. So on and off. And once again, the one with the NOT gate goes to on. And the one with no NOT gate goes to off, just like this. Now the latch gets hooked to the NOT gate and to the A side of the other AND gate. And this is just all the way down. So we're going to do this the same on this side, once to the A side of this AND gate and once to the NOT gate over here. And then we're going to go again, so once to the NOT gate out the back and once to the A side over here. Right, so that's actually most of this circuit done and dusted. Now what we need to do is do the connections between the lines. So the way we're going to do that is with falling edge gates. So what we're going to do is we're going to place 2 NOT gates and an AND gate at the back here. And then we're going to do the same over here with 2 more NOT gates and an AND gate, just like this. So you can do these whatever way around you like. I'm just doing them this way because it's going to work out okay. Then we're going to take, so this guy is going to feed into the second latch, and this guy is going to feed into the first latch. So what we want to do is we want to take, sorry, the third latch. We're going to take the first latch and run it into this NOT gate, and then we're going to take the first latch again and run it into the second NOT gate in that set, and the first NOT gate into the second NOT gate in that set, and into the A side of this AND gate. Oops, that's not what we wanted to do. I think that has indeed been hooked up. That's good. Okay. So then we're going to run the AND gate up into the B side of this AND gate and the other AND gate as well. So these are the 2 AND gates in the second latch. That's the ones that we want to use. So there we go. So this guy is hooked up from first AND gate through the pulse into the second AND gate. That's exactly what we want to see. And so now we're going to do the same thing second to third. So latch into both of the NOT gates that we have in the pulse, here and here. Then we're going to go and grab one NOT gate into the other NOT gate, and then the NOT gate into the output of this guy here. So there you go. That is exactly what we want to see. Now we're going to take the AND gate and run that into the AND gates in the third latch system. So here we go, into the B side there, and into the B side over here. Perfect. Now all that's left is to run the output into this guy, so we're going to run the output from here up into the B side there, and the B side over there. So now this is a fully working latch system. So counter system, that's what I was trying to say there. So this is a fully working counter system that we've now gone through and built. So that's the first part of this, although actually I still have one NOT gate and one AND gate in my inventory because we've forgotten the protection for this guy. So we're going to place that guy down and that guy down, and we're going to run the NOT gate into both the A and the B for this AND gate, just like that. And then we're going to run this AND gate into the B side of the two falling edge AND gates that we've got over here. So basically what this means is that it means the system won't start with an initial state when the island loads. It will start as a blank 0 when the island loads, which is good. We kind of want that, although we will be putting in a little bit of protection for that in just a little bit. But that's going to happen once we have everything else done that we need to do. So that's the first third of this circuit done. Now we need to move on and do the sequencer is the next part. Sorry, yes, we're going through doing the sequencer, and then of course we're going to go through and do our XORs to finish off the circuit. So the sequencer starts out looking very, very similar to the counter. What we're going to do is we're going to place down our gates and then our latches, I should say. So we're going to place down 3 latches just like this, and then we're going to place down 2 AND gates behind them, just like this, and like this, and like this, and like that, and like that, and like that. So there we go. Now we're going to go through, and exactly as we've done here, we're going to place down a NOT gate behind one of the 2 AND gates, just as we did before. So now hooking these things up, we're going to go through and go NOT gate into the A side of the AND gate in front of it, just like this, and just like this, and like that, and like that. So there you go. Now, the difference here is that rather than feeding the latch back into its own system, we're feeding the latch into the system up the line. So the first latch feeds into the second system, and the second latch feeds into the third, and the third latch feeds all the way back into the first. And we're also hooking these up a little bit differently as well. So this time, the one with the NOT gate, we want that to turn off this latch. So we go NOT gate goes into the off side of the latch it's attached to, and no NOT gate goes into the on side. And we do this all the way down. So no NOT gate goes into the on side, NOT gate, whoops, not the actual NOT gate, the AND gate for the NOT gate goes into the off, just like that. And same again down here. So the one with the NOT gate goes into the off side, one without goes into the on, just like that. Now we can hook up the lines between the latch and everything else. So the latch goes into the A side of the AND gate over 1, and it also goes into the NOT gate over 1, just like that. So that's the first into the second. Now we're going to do the second into the third. So here we go, we're going into the A side of this AND gate, and we're going into the NOT gate over there. Now we're going to feed back a little loop. So we're going to create a little node here, and we're going to feed back from the third. So the third is just going to go down to this node, and then we're going to connect the node together, and then we're going to connect the node to the first NOT gate, and also through to the A side of this guy over here. So there you go, that is now that little counter set up. All we need to do is connect up the inputs. So we're going to go and do that by taking our input from over here, which is this guy right here. We're going to take him and we're going to hook it up to every single one of this line of AND gates, and it's just going to go to the B side each and every time. So here we go, that's the B side there. This is going to take just a little while, but it is all of the B sides just along here. So we just need to make sure that we get every single one. If you don't get all of them, then it will get a little bit of a problem, but also it is a pretty easy problem to fix because it is literally just a case of hooking up that B side, because this basically what's happening here is that this input pulse is causing this whole circuit to switch states, and that is where we're going with this. It's just once again hooking up all of these to all of the B sides. Now that is now done. So the last little thing we need to do here is a little bit of protection. So there's 2 states that we don't want this counter to be in ever. So we don't want this counter to ever be all off, and we don't want this counter to ever be all on, because it's a sequencer, it's not a counter. So if they're all on, nothing can happen, it's just going to stay all on all the time. And if it's all off, the same thing, nothing can happen, because this circuit works by having whatever is happening in the first latch is copied into the second, whatever is happening in the second is copied into the third, and so on. So if there's nothing happening or everything is happening, nothing can change in this circuit, and then that makes it completely useless to us. So we really want to make sure that neither of those two things happen, and that's why we have all of these extra gates here. Now these extra gates are all about protection for the system. So the first thing we're going to do is we're going to do the nothing happening protection. We're going to face this backwards so that we know it feeds back into the circuit. Now the first thing we're going to do is we're going to run 4 NOT gates, just like this. Now the reason we're doing 4 is we're going to run 1 for each of the latches and then 1 for the pressure plate as well. Because what we want to do is we want it to be able to have no input while somebody's standing on the plate, but when they stand off, it can't have nothing happening. So we want to make sure that that's the way around this works. So we've got 1 NOT gate for each of the latches and 1 NOT gate for the input. So what we're going to do is we're going to hook all of those up right now. So we're going to take from the input and run that down into our furthest NOT gate all the way down here. Then we're going to run each of these latches in the red down into their corresponding NOT gate in this series. So here we go, NOT gate, and NOT gate. Now at this point it is the circuit is getting a little bit complicated, but basically you just need to do this slowly and in order, and everything should turn out okay. So now we need to AND all of these things together. So we basically want 2 AND gates that are going to AND 2 NOT gates. So each of these we're going to go A for one and B for the other, just like that. So now these two are ANDed together with this AND gate, and now we want this guy to AND together with these two, just like that. And now we need to AND those all together here. So we're just going to once again run both AND gates. One of the AND gates goes into A and one of the AND gates goes into B. The order doesn't really matter, just whatever suits you best. So now you can see that that's currently turned on, and what we want is when that turns on for the first light in the sequence, this guy down here, we want that guy to be on. Because when these turn on all at the same time, it means that the system is currently set up like this, where nothing is turned on and nobody's standing on the pressure plate. So we want a signal to go through into the system. So to do that, we use a rising edge pulse. So we want an AND gate and a NOT gate, just like this. And we want to run the AND gate that ends all of those NOTs together into this NOT gate and into the B side down here of the furthest AND gate, and then the NOT gate goes into the A side, just like this. So that's our little rising edge pulse, and now we have a rising edge pulse. We can feed that all the way into the on of the very first latch up here, and you should see that that turns that latch on. So that's beautiful. That means that that system is now working. So now we want to finalize this little piece of the circuit by doing the all-on protection. Now this one is actually easier than the last one. This one had a lot more gates in it. So we're going to place our all-on protection just down here. What we want to do is we want to stagger 2 AND gates like this, because these are just going to be used to link all of the latches together. So we're going to run one latch into the A side of this guy, and then we're going to run another latch into the B side of this guy. And then we're going to run that into the A side up here, just like that. And then we're going to run the final latch that we haven't run yet all the way down into the B side down here. So now this AND gate here is going to turn on when all 3 of those latches are on at the same time. So now we want to use a quick little rising edge pulse. So this is once again just a NOT gate and an AND gate like that. And we're going to hook all of these together. So AND gate goes into the NOT gate and into the B side down there. NOT gate goes into the A side, just like that. And so now we have a gate that is going to turn on and pulse once when all of those lights turn on together. Now this shouldn't happen realistically, but you just want to make sure that it's really, really not going to happen, and that's why we've got this little gate down here. So to finalize the circuit, what we're going to do is we're going to run this guy up and have that turn on the first latch and then turn off the other 2 latches. So it's basically going to be a system reset. button. When that all happens, it's going to turn on the first one and off the last two. So that's exactly what I'm doing. I'm just running it up here, putting it on there and turning them off. So that's just going to be a quick little pulse that goes through the circuit and just resets it back to the base state, so that will sit there and it will be fine and it will be okay. Everything will be fine. So now we are finally going to go through and do the actual output system to this guy. So to do the output system, what we're going to do is we're going to come up a little bit further and we are going to place down a couple of nodes, which are just two NOT gates, just like this. And we're going to line. I'm going to line mine up with the sequencer design that I've done just here. So the very first latch, the very first node that we've got here, we don't want to do anything funny with this. We just want to use this exactly as it is, and that's going to be fine as it is. So I'm just going to go through and connect all of these nodes up. So we're going to use this latch exactly as it is, just connected down to the first latch over here in the counter. So that's all we're going to do with this. We're going to take the first latch in the counter and we're going to hook it all the way up to our first node, and that's done. That's all that needs to have happen. These other two are a little bit more complicated. We're going to use these and do these as our XOR systems. So basically we want to go through and do these as XORs. So that's going to mean they get two NOT gates each and two AND gates each. So you put down the AND gates first, just like I'm doing, and then we put down two NOT gates, 1 and 2, and 1 and 2. Okay, so now this gets a little bit complicated in terms of where things are and what you're hooking up where. So what you need to think about is that you're going to hook this latch. This latch is your A for this guy, and then this latch, the first latch in the red set, is your B for this guy. So that's what we're going to work on doing here. So first of all, we need to set up our actual AND gates and NOT gates here. So the AND gates run into the first NOT gate in the little node that we created, just like that. Now the NOT gates run into different connections. So the first NOT gate goes into A, like that, and the second NOT gate goes into B, like that. So now what we're going to do is we're going to hook up this guy into that circuit. So this guy, as I said, he's the A connection in our system. So he's going to hook up to the A side of the first of this AND gate here that we hooked the NOT gate to the B of, and then he's going to hook to the NOT gate connected to the A of this other latch, like I said, because that way he's into the A of this side and he's into the A of that side, and that's perfectly fine. That's exactly what we want. Now this latch is the B of that system, so we want to hook that into the NOT gate connected to the B, and also into the B side that doesn't have a NOT gate connected to it. So just like that. So now that whole system there is now set up and running correctly. That's exactly what we want. And as you can see, this should be outputting right now because this guy is on and this guy's off, and we've gone through an exclusive OR. Because they're different, that means there's an output, and that means that this light here is on, and that's perfect. That's what we want. We like that. That is good to see. Okay, so now that we have that, now that that is up and running, we want to do the same, but with this latch here, the third latch in the counter, and the second latch in the sequencer. So once again, the counter latch is going to be our A, and the sequencer latch is going to be our B. But first, of course, we need to actually hook these up to where they're supposed to be. So this NOT gate is going into the A up here, and this NOT gate is going into the B down there. And then these AND gates are going through into our node, just as before. So there we go, just like that. Not a problem at all. So now, as I said, we're going to go through and connect this guy to the A's. So he goes to the A on the closest AND gate, and to the NOT gate on the furthest AND gate over here, because that way he's hooked up to the A of all of this circuit. And then this guy's going to the B, so he goes to the closest NOT gate and into the B side of the furthest AND gate, just like that. So there we go. Now all of that is hooked up, and we have our output set and ready to go. The only thing we need to do now is actually protect this and make sure that nothing the output of nothing is not ever used. So what we want to do for this is we want to set up a system whereby when the pressure plate is off, we're going to want to have something on here. Like, we don't want all of these to be 0 at the same time. So I think I actually need one more NOT gate to get this system working. But at the same time, we're going to just quickly place down. So we need two AND gates, I should say, to hook up all of the latches or all of the nodes and the input. And then we're going to need an AND gate to connect those all together. And then we're going to do a quick little rising edge pulse to then reset either the counter or the sequencer. I think we'll reset the counter with this one though. So the first thing we want to do is, before I go and make this extra NOT gate that I missed out on, we're going to want to hook all of the NOT gates from the latches, from the nodes here, into one of the sides of an AND gate. So the first one goes into the A of the first one, the first AND gate. The second one goes into the B, right here, of the first AND gate. The third one down the line goes into the A of the second AND gate. And then I'm going to place down the NOT gate that I have here. Actually, that's the wrong NOT gate. We need an input NOT gate to do this. So I'm just going to quickly make an input NOT gate, and then we'll be okay. So there we go. This is our input NOT gate. Now, this is an extra NOT gate on top of what I said we needed already, but we're going to run a line from the pressure plate all the way down to this input NOT gate, and then we're going to run that input NOT gate into the B side of this final AND gate here, just like that. And then we're going to AND these two things together. So we're going to AND this with that at the A side, and then this guy is going to go into the B side down here. Perfect, just like that. Now finally we're going to turn this into a rising edge pulse by adding in one NOT gate and one AND gate, and doing this as we've always done rising edge pulses, by hooking this AND gate into the NOT gate and into the B side down here. Perfect, and then all of that goes into the A at the top, just like that, and then all of that stuff gets run all the way down to the very first latch in this counter, and we're just going to turn that on, just like that. So now, as you can see, when this system is turned on, two of these nodes are turned on, and that's okay, that's fine. It just means that there's no 0 state for this, which is exactly what we want. Now, the final thing to do, obviously, is to hook up the lumostone lights, which determine what the actual output of this thing, or show the user what the actual output of this thing is. I'm just going to hook these up one at a time, and you'll be able to see that we have two lights on and one light off. And if we go over and stand on the pressure plate, it will randomize what's going on. So let's go down here and stand on here, and you can see it will just kind of flick back and forth in a very random state, and you really won't be able to tell exactly what's going on here and what's going to happen when you stand off the pressure plate. So there you go. This has been a much longer tutorial than most of my other tutorials. This is probably one of the most advanced tutorials I think I've ever done. But there you go. That is it. This is the advanced randomizer that I have built here in SkySaga. Hope you guys have enjoyed that one. I hope this is useful to at least one person out there, and I will see you in the next episode.